Hello, this is my Physics 2212 Lab 4. So, lab overview. So the purpose of this lab was to use the ammeter and the voltmeter in order to observe how different circuits work. In particular, we looked at the potential difference and the current and see how that differs between different parts of the circuit. So across different resistors and ammeters and voltmeters. So for physics principles, we use the conservation of charge as well as the energy conservation. So what this does is it says that the current and voltmeter cannot just disappear or appear in a circuit. We also took a look at capacitance as well as currents in series and parallel. So for part 1 of the lab, we used the V equals IR to create a prediction of the current in the lab. So for resistance, we had 147 ohm and 100 ohm. So the total resistance would be 147 ohms because of the circuit being in series. So solving for I, we got 0.0204 amps, which turns out to be the same thing as the model. In this part, we also flipped one of the ammeters and we turned out to have the same reading, positive 0.02 amps. So part 1 continued. So in this part, what we did was we took out one of the ammeters and instead put a voltmeter there. The voltmeter read 3 volts. However, the current was 0 because the current cannot flow through the circuit. So then what we did was we took the potential difference across different parts of the circuit. So from A to B, that is from one end to the other end of the battery, was positive 3 volts. And then we measured the potential difference for all the other parts of the circuit. If you notice here, you'll see that the sum turns out to be 0. Okay. So for this part of the lab, we put an ammeter in parallel with one of the resistors. Pretty sure this is the 100 ohm resistor. We turned out to get the same current going through the ammeter as the other part, which is in series. This is because the ammeter has a resistance of 0. So instead of the current going through the resistor, it goes through the ammeter. So although it's in parallel, it's essentially a series circuit. Alright, so for the RC circuit part of the lab, we had 2 different parts, one involving a 10 ohm and another involving a 20 ohm bulb. So what we did here is we created a series circuit with a battery, a light bulb, and a capacitor. So whenever you place a battery in a circuit with the capacitor, it charges the capacitor up. So you'll notice at the start, the light bulb lights up. However, as time goes on, it gets weaker and weaker as the capacitor becomes full. So for the 10 ohm, it took 8.64 seconds to charge and 9.24 seconds to discharge. So for discharging, what happens is you take out the battery in the circuit and all the charge that's in the capacitor starts flowing in the opposite direction. And that's how it discharges. For the 20 ohm bulb, it took 14 seconds to charge and 18.3 seconds to discharge. So these numbers seem approximately correct because they're double as the 10 ohm bulb, which makes sense because the resistance is doubled. Then what we did was we found the potential difference across the capacitor, and then we took 20 data points and graphed that. So we found the slope of the ln of v over v naught versus time graph to be negative 0.167. And we know that this slope is equal to negative 1 over RC. And then solving for RC, we get 5.988 seconds, which is very close to the actual RC value of 6 seconds. So we know that we did this lab correctly. So some reflection questions. What if you were doing this lab in real life and used an actual ammeter instead of an ideal simulated ammeter? What's different about a real ammeter and how would it have affected the circuits you hooked it up to? So a real ammeter doesn't have 0 resistance. So in this lab, since it's the ideal circuit, it has an ammeter of 0 resistance. But in real life, it wouldn't be that case. Therefore, the current would be a bit smaller because the resistance would be a bit bigger. So what if you were doing this lab and used a real battery to charge a real capacitor with no resistance in the circuit? How quickly would the ideal model predict the capacitor to reach full charge? How will this prediction happen in real life? Explain. So in real life, the capacitor would not charge instantly because batteries have like a very small internal resistance. However, in the lab, this is not the case. So in real life, it would take longer to charge. Alright, so that's my lab. Thank you for listening.